So these are your notes over significant figures. Just kind of take them as we go. Significant figures come from measurements. So, for example, in the lab, we record data. What we're doing is creating significant figures. It just basically means this is a way of knowing how reliable the numbers that we're looking at on the page are. Can we depend on a number to the nearest tenth, to the nearest hundredth, or maybe only to the nearest thousand? We don't. It just depends on the number of significant figures there. So there are the digits that can be relied upon. Okay, that's another way of saying it. And again, you want to pause and write these down. These are your notes. So an example would be if you saw this statement written two different ways. A building is 300 meters tall versus a building is going to be 318.2 meters tall. So there's a big difference in saying those two things because they're both about the same number, but one of them can only be relied on to the nearest 100. So it might actually be that the building is only 298 meters tall, or it might be 320 meters tall. It's been rounded to the nearest 100, and we know that because the 3 is the only significant figure. And so basically to be able to say that, we have to understand what significant figures are. So in terms of determining which digits are considered significant figures, I've got 3 rules to give you. Just keep doing that, sorry. One is that all non-zero digits are significant. So if you see a number 12.57 meters, that's 4 significant figures. That means all 4 of those digits are considered significant, or you could say reliable. Okay, so 12.57 has 4 significant figures. Or another way of looking at it is it's a number that is good to the nearest hundredth because its last significant figure is in the hundredths place. All right, then we have, Then we have captive zeros. So like in the number 200,015 pounds. So the captive zeros are the ones that are in between the non-zeros. Now just to be clear here, the captive zeros are significant, all 3 of them, but because of because of the previous rule, rule number 1, so are the non-zeros. So actually all digits in this number would be significant. Or you could also say, since the number is 200,015 pounds, this number is reliable to the nearest 1 pound. Okay. Then we have trailing zeros. So trailing zeros get a little bit tricky. Trailing zeros are significant if the number contains a decimal. So if I have 2.50 grams, that is a trailing zero because it comes after the last non-zero. That's what makes it a trailing zero. And what makes it significant is that there's a decimal in the number. And then once again, of course, the non-zeros 2 and 5 are also significant. So this number would be good to the nearest hundredth, or you could say it has 3 significant figures. These guys out here in front in this next number, 0.007200, are not trailing zeros. They're just placeholders. These guys at the end, though, after the 2, are trailing zeros, and because there's a decimal in the number, they are significant. And of course, so are the 7 and the 2, because they're non-zeros. Right? So that basically leaves us with placeholders. Placeholders are not significant figures. So what's a placeholder? A placeholder would be like 470 pounds. Has a placeholder, a 0, in the ones place. Okay? So this is a trailing 0, but there is no decimal. So therefore, it does not fit in with rule number 3. It is a trailing 0, but it does not contain a decimal, so it's just a placeholder and therefore not a significant figure. Well, what does that mean? It means 2 things. It means that this number only has 2 significant figures, which will be important when we talk about rounding a little bit later. It also means that this number is not reliable to the nearest 1, which is where the placeholder is. It's reliable to its last significant figure, which is the 7, which is in the tens place. So this 470 pounds is really only good to the nearest 10 pounds. It might be 468, it might be 473. We don't know because it has been rounded to the nearest 10 pounds. Placeholders would also be the ones that come before the first non-zero. So the 5 is the first non-zero in this number. The 5 and the 8 are, of course, significant, but these guys are just placeholders. Now, when we say they're not significant, that doesn't mean that we get rid of them. We can't drop them off. We don't want to turn the number into 0.58. It's still going to be 0.0058. And that's important because those two numbers have very, very different meanings. So, significant figures are just a way of understanding which numbers in a measurement can be relied upon, which ones are significant just is determined by how precise the measurement was. And we can do that. We can identify that by these three rules.